Okay, so lesson 75 is about graphing radical functions. And before we start anything else, what you guys should know is that a typical radical function, for example, maybe I should just say the parent function, because I think you guys are used to that terminology, right? The parent function. Okay, so the parent function of y is equal to the square root of x looks like this. Okay, so put that into your notes, because that's kind of the template, I guess, is one way to think of a parent function for all other radical functions, all right? Well, I guess I should say for the square root function. We're going to also be looking at cubed root functions today, and those look different. But at least for the square root function, you know what's going on here. Now, because of what you know about translations, you know what I mean by translations? When it goes up on the up or down on the y-axis, or left or right on the y-axis. Okay, so because of what you know about that, if I would give you y is equal to the square root of x minus 2, for example, do you see that that would actually be over here, right? Because it was shifted 2 to the right. Does that make sense? Okay, so the rules about translations and left, right, up, down shifts, I guess, if we call that, a translation, which we can, that still applies, all right? The thing is, I'm not going to make you graph these radical functions manually. You would spend so much time doing the algebra just to get it graphed that by that time you'd be completely out of energy to analyze it, all right? So the idea is we're going to figure out how to put them into Desmos, and then we're going to analyze them. Do you remember domain and range? That is going to be an important discussion here with this. So for example, this green one, right? Y is equal to the square root of x. What is the domain of this function? Actually, let me make this be green so that you can keep this straight, right? Okay, so what is the domain of this parent function? Where, in other words, what values of x are we allowed to choose? Yeah, all reals, right? All reals greater than or equal to 0. Do you see that? Yeah, that's pretty straightforward. Okay, so what's the range? What's the range? Yeah, all reals greater than or equal to 0. Okay, now technically though, do you see that we could call this all x is greater than or equal to 0, right? Because domain means x. All right, we could say all y is greater than or equal to 0, and that would be equally correct. Everybody good on this? Okay, so that domain range discussion we're going to be having probably to the point of you wishing we hadn't had it, but too bad, right? Okay, so let's look at this here. So this, I know this g of x thing is just ugly underneath there, right? Can you just kind of mentally imagine that it's something not so ugly, that it's just a function like I showed you a minute ago? It's like I showed you just a minute ago, you had f of x is equal to the square root of x minus 2. See, that's not as intimidating, right, as this g of x thing. So this is the radical version, all right? So the fractional exponent version looks like this, of the very same thing. F of x is equal to x minus 2 to the 1/2 power. We've talked about this before, that if it's raised, anything that's raised to a fractional exponent, that is the same thing as the square root. Okay, so this is not, this notation of something being raised to the fractional exponent should not be new for you, okay? The thing is, I don't really love the whole fraction exponent thing, so usually if I see a fractional exponent, I'll just change it right away. I'll just say, oh, I know that means the square root, so I'll say x minus 2. Does that make sense? Because then when I get this, then I'm like, okay, well, I'm familiar with this, so I'll be familiar with this as well. All right, so let's get started. And for those of you who are watching the video, you can see I've got the screen big. And the reason I have the screen big, showing all this Mimeo stuff on the sides and all of my stuff on the bottom, is the Desmos has to be visible. The whole screen of Desmos has to be visible. So what I want you to do is start. Well, it says graph the square root function and its inverse. All right, so we're going to be finding the inverse, and then we also have to determine domain and range of both functions. So we're just going to do that systematically. So the first thing I want you to do is just graph the square root function. So let's put y is equal to the square root of x minus 1 into Desmos. All right, so you do that, and I will do that as well. So y equals the square root of x minus, is it x minus 1? I think so, right? X minus 1, all right? Okay, well, from what I told you just a minute ago, doesn't that match with what you already know? Do you see how this thing was shifted over 1 unit to the right? No surprise there, is there? Okay, all right, so now we could evaluate, actually we could evaluate the domain and range pretty easily, couldn't we? What is the domain right here? Noah, what's the domain?
All reals greater than 1.
Yep, exactly. So come back here, back to this, and we're going to say, I'm going to say original because we have to write the original and the inverse function. And we have to find the domain and range of both the original and the other one. So the domain is just what Noah said. All reals greater than or equal to 1. Okay? All right. And what's the range? What was the range? Alex?
All reals greater than or equal to 0.
Yes. All reals greater than or equal to 0. In other words, everything above the y-axis. All right? Or at the y-axis and above. Do you see that right here? Okay. So now, okay, let's go back. Now we're ready to do the inverse. Okay? So first of all, we have to write the inverse. What do we do when we write an inverse function? Cody, what do we do? When we're writing an inverse function.
Swap out the x and 1.
Exactly. So let's do that. You guys do it at your seats. I'll do it up here. So x equals the square root of y minus 1. I think I did that right. Okay. Now do you see what the problem is here? We have a radical. We need to get y by itself, right? In order to graph it, we need to get y by itself. So let's do that. But what do we do? What do we need to do to get rid of the radical, Brianna?
Square both sides.
Square both sides. So we can do this. Square this, square this. So now we have a statement that says x squared equals y minus 1. All right, no big deal. Bring the 1 over here. We should end up with y equals x squared plus 1. Does everybody see the math I did on that one? Hopefully that's not too big of a stretch for you. Okay, so now we graph this. Okay, so back to Desmos, and well, you guys already see that it's going to be a quadratic equation, don't you? Y is equal to smell here. Wait a minute here. I need to get a new equation. Y equals x squared plus 1, right?
Mhm.
Yeah, plus 1. Okay, cool. All right. So this is good. Now, here's the thing though. Here's the thing about this. This is where the domain and range stuff gets a little bit tricky. Because if you just take this parabola at face value, it looks like the domain and range are super easy to find. Because you just evaluate it, right? Not so fast. Here's what happens when you're evaluating the domain and range for an inverse function. And this is the part that I was confused about a few minutes ago, and the light dawned, thankfully, just in time. So I'll come back to this in just a minute. We've graphed this, which is what we were supposed to do. So let's come back here and talk about the domain and range of the inverse. And I'm going to change this color here so we can keep these separate here. So the domain and the range. All right, here is the deal. When you have whatever the domain and range were of the original, they switch for the inverse, which I feel like is not too big of a stretch because we switch the x's and y's, right? So like that's not too weird. Okay, so the domain then is going to be all reals greater than or equal to 0, right?
Mhm.
And then for the range, it's all reals greater than or equal to 1. Make sense? I think. Did I do that right? Yeah, because I brought this into the range location. And then I switched this, and then I switched these. You see it? So if you can properly identify the original domain and range, The inverse domain and range are pretty easy to find if you know how to, switch. Okay? All right. So let's come back here now because I want you to see something in Desmos. We said the range was all reals greater than or equal to 1, right? No. What did we say? I can't remember even. The range for the inverse function was all reals greater than or equal to 1. Yes. Okay, so now I'm going to take us to Desmos and show you. So right here is where it kind of starts, okay? You see that? So there's kind of a correlation there. Now, I know this is kind of weird, but I want you to add one more function because I want you to see something. So add this new function, and this is a really, really easy function to add. Y equals X. What do you see about the green line? Or your color line is probably, yeah, it chooses the. Do you see that there is something we call symmetry? Okay, that is the case for all inverse functions. All inverse functions are, if you've done it right, they will have this line, y is equal to x, they'll have that as a line of symmetry. So you can always tell if you've done it right or not if it doesn't look symmetrical across from the line of symmetry. If the two functions are not reflections of each other across the line of symmetry, then we have a problem. Okay? Now, do you see where the symmetry goes? Whoop, okay, right here, we can look at this. Do you see this part right here? The symmetry is not accurate. The symmetry starts right here. Okay, so the symmetry starts here and here. But that's okay. The problem with Desmos is we don't really have the ability to just make this go away. So I guess technically what we could do is we could just pull this down here so we can't see anything except this. Does that make sense? Now you can see the symmetry a little bit better. Yes? Everybody good? All right, so let's come back here, and we've taken care of that. All right, so we've got example A done. Now, what are you going to do when you have to do these on your homework? You are going to graph them, and you're going to take a screenshot, and you're going to show me. Right? You know how to do a screenshot? Yep. So that's easy, right? Yeah, you guys probably know how to do screenshots better than your parents and grandparents for sure. All right, so the